Good morning, everybody. We have I guess I would call this a challenging combinatorics problem. We're trying to count the number of natural numbers n such that this quotient is actually an integer. Now we get a cheap one real quick by inspection. Notice that if n equals to -3, right, then n plus 4 is equal to 1. All right, so that's a no-brainer, right? We don't have to calculate the numerator. If n is equal to -3, we have 1 down here. So whatever this is going to be an integer. And so there's at least 1. We know that right now. But how many total is the question, okay? So I won't go through the steps on the synthetic division. It's rather tedious, but not difficult. If you do the synthetic division, we get the object of interest equals this quotient remainder sort of form, okay? Quotient and then what divisor remainder sort of structure here. Now, a very nice thing happens here. We know that this piece right here is always going to be a member of Z, right? This part right here is guaranteed to be a member of Z without even blinking an eye, right? Maybe winking but not blinking, right? Okay, so what can we do though? Well, we can observe that if n plus 4 is a divisor of this, then that's going to solve the problem. Anytime that happens, this guy here is going to be an integer, right? If n plus 4 is a divisor of 1005, this part right here will also resolve to an integer, right? So it's a matter of just counting the divisors of 1005, and you know there will be that many solutions. So this is just linear, right? So let's take a look at 1005. 1005, I can write it right here, I suppose. 1005 is definitely divisible by 5, and it's also divisible by 3 since the sum of the digits is divisible by 3. 5 plus 1 is 6, divisible by 3. So we know we're going to have, well, I'll just write it down. Again, I won't take the time to calculate this, but it's 3 times 5 times 67. Okay, takes a little bit of time to do that, not long, but 3 times 5 is times 67 is 1005. Now notice we have understood exponents of 1 here. So you see, it turns out the total number of divisors would be 2 times 2 times 2. Equals 8 divisors. Okay, divisors, let me write that right up here. So we have 8 divisors. And again, you can just pair these up and see how that works, folks. This is a known combinatorics result where you just increment each of the exponents because you're allowing for an exponent of 0. So we have 8 divisors, but they can be plus or minus, okay? So we can have n plus 4 can equal to plus or minus any of these divisors. Okay, we'll call it D equals 8 divisors here. Okay, but there's 8 of them, right? And so that means n plus 4 can equal to 16 possibilities. Okay, integers. Okay, so that's our answer. Now, for those of you who aren't satisfied with that, this is the theoretical way to do it right here. We never even had to calculate any divisors, but this is going to be our answer. N plus 4 is equal to 16 integers, and in each case, this would resolve to an integer. If you're doing the 8 divisors of this, they're plus and minus counterparts, right? You have positive divisors and you have negative divisors, right? And if you don't believe this, if you're not satisfied with this, let's just take a look at a couple of the possibilities. Let's write down some of the divisors of 1005, okay? According to this prime factorization right up here, 1, 3, 5, 15. We can just write them out if you want to. 15. Okay, that's 3 times 5. Now what about 3 times 67? 3 times 67 is what? 231, 180, 201. Right, folks? And that's supposed to be 3 times 67 up here. 3 times 67. And 5 times 67 is what? 335. Okay, now what? Let's see. There's 8 of them out. We have 1, 2, 3, 4, 5, 6. What else do we have? Did we forget 5 times 67? Let's see. These are just a few of them. I'm missing one of them, but we don't really need to know all of them. I may be missing one at this point. This is the answer, by the way. I'm just trying to go through all the divisors. Let's see. 3 times 67 is 201. 5 times 67 is 305. Okay. We got 15 in there. It seems like I'm missing one. One of them, of course, is 1005. Right. And y'all, anyway, it looks like I'm missing one. I can't see it right off the top of my head. It should be, okay, 3 times, okay. Now let's see, is this, how many is this? 1, 2, 3, 4, 5, 6, 7. There's one that I'm missing for sure. But anyway, we won't belabor the point, but notice that, and also you could put plus or minuses in front of all of these, right, folks? Plus or minuses. But in any event, you can equate n+4 to any of these divisors, and you'll get this piece right here being an integer. Okay, but again, this is the answer to the question, 16.